Picture this. You're looking at a landscape, right? But it's bathed in this surreal crimson-tinted light. And the craziest part? Your passing thoughts aren't just staying in your head anymore. They're literally crystallizing into moving, breathing scenes right in front of your eyes. Well, welcome to today's Explainer. We're taking a deep dive into the synthesis of reality, exploring the absolute bleeding edge of XAI's capabilities, specifically focusing on Imagine video generation. We're looking at a piece of tech that is fundamentally changing how we create, how we consume, and even how we understand the moving image. So that brings us to a pretty profound question to start things off. What actually happens when the boundary between a simple typed-out text prompt and a vivid, high-def dreamscape just completely vanishes? Because we aren't just asking computers to retrieve information for us anymore. We're literally commanding them to hallucinate entirely new, moving realities right on demand. And guys, this isn't science fiction. This is exactly where consumer technology is sitting right now. Okay, let's dive into this. At the very center of this massive paradigm shift is Grok Imagine. To break it down simply, Grok Imagine is XAI's dedicated image and video generation tool. Think of it as the engine that takes your text prompt or an existing image or even another video and translates it straight into an animated audio-visual clip. It basically acts as the visual imagination for the entire Grok ecosystem. And what's truly staggering here is just the sheer velocity of this development. I mean, it's moving fast. Back in July 2025, Grok Imagine first launched with these brief little 6-second clips. Elon Musk even called it an AI Vine. But, the tech obviously didn't sit still. By February 2026, boom, XAI rolls out Imagine 1.0, complete with vastly improved audio. And then, literally just a month later, in March 2026, they dropped the Video Extend feature. Suddenly, users are stitching together clips up to 30 seconds long in crisp 720p resolution. So in less than a year, we went from these quick, silent glimpses to half-minute high-def realities. All right, but let's snap sharply out of that surreal magic of creation for a second and look at the hard, concrete math. Because generating all these realities, it requires a massive amount of computational power. We're talking gigawatt-scale superclusters down in Memphis. So you might be wondering, what does generating these realities actually cost the end user? Let's ground the stream in the economics of synthesis. For everyday consumers, XAI set this up with some very specific subscription tiers. On the entry-level side, you've got the Super Grok Lite plan. That's $10 a month. It gives you 15 video renders a day, but they are capped. You're looking at 480p resolution and just 6 seconds in length. Now compare that to the standard Super Grok tier at $30 a month. Here, those constraints pretty much fall away. You get roughly 100 renders a day, bumped up to 720p, and your base clips are 10 seconds long. It's a really stark contrast between getting a limited taste of the tech and having this massive, relatively unconstrained flow of daily generation. But the underlying strategy becomes incredibly clear when we peek under the hood at the developer API. $4.20. Yeah, it's almost absurd in its exactness, but according to the source pricing, that is the exact API cost to generate a full 60-second 720p video clip with audio using Grok Imagine. And this brilliantly illustrates a highly disruptive pricing model that's clearly designed to aggressively capture the developer market. To really understand why that $4 number matters, we have to look at the broader landscape. Generating a minute of video costs $4.20 on Grok Imagine, right? Well, over on Google's Veo 3.1 preview, that exact same minute costs $12. And on OpenAI's Sora 2 Pro, you're looking at a whopping $30 a minute. So Grok Imagine is roughly 7 times cheaper than Sora 2 Pro. From a pure economic standpoint, that literally makes it the most cost-effective, serious video generation model currently available on the API. Now let's reverse the flow of information for a second. We've talked a ton about how Grok creates video, but what happens when we feed the real world back into the machine? We're transitioning now from video generation to video understanding. And this was a major, major leap introduced with XAI's new flagship model, Grok 4.3. This builds a very distinct technical advantage. Grok 4.3 actually features native video input. It processes frames directly through an integrated vision encoder. Basically, it naturally sees the moving image without any external conversion lag. Now, compare this to a top-tier competitor, say Claude Opus 4.7. Claude entirely lacks native video support. It actually forces users to manually pull screenshots and run them through optical character recognition just to figure out what's happening in a scene. It's night and day. So, why does this matter? The absolutely crucial point is what this native video input unlocks for everyday practical workflows. Let's say you're a digital strategist or a developer. You can now upload a simple screen recording of an app directly to Grok 4.3 and just ask it to write the underlying code. Or you upload a quick video of a software bug and Grok hands you an automated fix. Designers can upload a UI animation and the model translates that motion directly into front-end code. It just entirely removes the friction between visual reality and digital execution. It's a real game changer. However, as we go through the source material, it's absolutely necessary to step back and objectively look at the broader implications of this unconstrained technology. We need to shift our focus to the societal controversies and the real-world risks associated with synthesized reality. Reporting strictly on the facts detailed in our sources, the deployment of Grok Imagine has not been without significant controversy. The tool actually includes a spicy mode, which is designed to bypass typical industry safeguards, allowing for the generation of explicit and NSFW content. According to multiple reports, this lack of guardrails directly facilitated the creation of non-consensual sexualized deepfakes of real people, including minors. The sources highlight this as a deeply harmful abuse of the platform, and, unsurprisingly, these incidents sparked an immediate and severe EU regulatory crackdown, along with widespread public calls from various jurisdictions to ban the platform entirely. Setting aside those present-day controversies for a moment, the sources also detail xAI's overarching philosophy. Their stated mission is, and I quote, to understand the true nature of the universe. It's a massive, highly ambitious goal, but it informs exactly where they are steering their infrastructure next. That philosophical ambition is what's driving their aggressive push into the absolute next generation of multimodal technology. And that brings us to what's right on the horizon, Grok 5. It's scheduled for a public release in late 2026, and it's currently training on the Colossus 2 supercluster. Guys, the leaked specs are just staggering. It's built on a massive 6 trillion parameter mixture of experts architecture. That basically means it relies on a whole network of highly specialized submodels working together to solve really complex problems. But the biggest takeaway for our topic today, it is natively multimodal from the ground up across text, image, audio, and video. Grok 5 will actually introduce real-time temporal video reasoning. That means you won't just ask it to analyze a video, you'll be able to ask it instantly, hey, what exactly happened at the 2-minute and 34-second mark? And it will instantly understand the precise temporal context of that visual reality. Which leaves us with this final thought to ponder. As the technology to generate, understand, and manipulate video becomes cheaper, faster, and infinitely more capable, that boundary between what is real and what is simply rendered is rapidly melting away. So what you should take away from this explainer today is this. Will our future be defined by the physical realities we actually observe, or by the digital realities we can now instantly synthesize? Thanks for joining me, and as always, keep questioning what you see.